Hello everyone, in this lecture we are going to talk about multivibrators. So what is a multivibrator? So multivibrator is a device which requires no input. Output will be in the form of a square wave and the state switches between on and off. On is 1 and off is 0. So on state may be plus 5 volt, 1, off state may be 0 volt, which is 0. So this plus 5 volt, if we keep VCC as 5 volt, the output will be plus 5. If we keep VCC as 10 volt, it will be on state will be 10 volt. The amplitude will be 10 volt. This is the 0 and 1 state, constantly switching between 0 and 1, off and on state. So there are various types of multivibrator. First one is Astable multivibrator. So the second type is monostable multivibrator. Astable multivibrator is the one which keeps on switching between states 0 and 1. The word astable means it is not stable. It switches between 0 and 1 continuously. So this one, the amplitude depends upon the VCC supply given to the transistor. So if you can see here, I have given the link for the operation of a transistor as a switch on condition and switch off condition. Here for on condition, VBE should be greater than 0.7 volt. IC will be reaching the saturation value. When IC reaches the saturation value, VCE will become 0. So this is the condition where the transistor works as a on state. Here in off state, what will be the condition for a off state? Switch off condition, VBE less than 0.7 volt. If it is less than 0.7 volt, IC will be 0 and VCE will be equal to VCC. This VCC, the supply voltage here. Whatever voltage we give here will reflect in the output. So there are two terminals here. VCE terminal 1, we call it as VCA. Here VCB. So we are going to take the output from VCB terminal. So there are two output terminals. Any one terminal we can take the output. So we take the output from that terminal, VCB terminal. So if we start the operation, if we give 5 volt plus 5 volt here, at a time there will be only one transistor on and another transistor will be off. So this transistor is Q1 and this transistor is Q2, and we want to take the output at VCB. Here if we can see, let us consider that this Q1 is at on condition. What will be the cases, changes occurring in this transistor if it is at on condition? It means VB is equal to 0.7 volt. Supply is supplied. Consider Q1 should be on and Q2 is off. We will see how that condition happens. First, if Q1 is on, what happens is VB is greater, it means VB is greater than 0.7 volt and IC is equal to IC saturation, maximum value. So this acts as a switch, closed switch, where IC becomes maximum, current flow is maximum. So if you measure the voltage terminal across VCE, what happens is we get 0 volt. Here 0 volt. Now this 0 volt is taken here, is tapped out from this terminal to the ground and then moved, and this 0 volt is applied as the supply to this base to emitter terminal. This is base to emitter terminal. This VCA 0 volt is applied here. What happens is this transistor goes to the off condition. How off condition? This VCA is realized as 0 here, and when it is given a supply here, it is automatically acts as a supply for this base emitter junction. So this transistor goes to off condition. So if it goes to off condition, this becomes open circuit because IC2 is 0. So if this transistor is off, IC2 will be 0 and this will be the open circuit. And if you measure VCE, voltage across VCE, which is VCB, we get plus 5 volt. If that is plus 5 volt, I already said that that is the point where we measure the output. It will be one state. This is 1 plus 5 volt. Okay. So we have achieved that on state condition from this astable multivibrator. Now how does the state changes? Without one important point in astable multivibrator is without any external trigger, this state will be changing from 0 to 1. See, the multivibrator means that it changes states 0 and 1. The thing is whether the state changes by giving the external trigger or without giving the external trigger. Astable multivibrator changes from 0 to 1 or 1 to 0 without any external trigger. But monostable multivibrator changes state only after we give trigger. So here the on state is realized. Now how does it changes the state? Here if you can see, this transistor is off now, plus 5 volt we have achieved. When this transistor is off, this capacitor starts charging. It starts charging in a way that the voltage across this capacitor C1 becomes VC1. So if this becomes VC1, this is supplied again to the base of this transistor, base emitter junction of the transistor. So what happens is VB, which was before less than 0.7 volt, now becomes greater than 0.7 volt. If this base emitter junction becomes greater than 0.7 volt, what happens is this collector current becomes maximum. If this collector current becomes maximum, it means it flows as a current from collector to the ground, because this circuit becomes closed. Based on the principle of working of a transistor in switch on condition, this collector current reaches saturation value because VB goes to greater than 0.7 volt. This becomes maximum and current flows. Now the voltage here, since this terminal is shorted, this collector and emitter terminal is shorted because of the saturation state of the collector current, this plus 5 volt state changes to 0 volt. So if again the output is going to be measured at that point only VCB, and it goes to 0 volt, 0 volt or state 0. If this is at state 0, this VCB is there, right? This VCB 0 volt is realized as the supply of this VCB is realized as a supply of this transistor base emitter junction. This VCB now it is 0, and from here if you measure here it is 0 volt. Again if you here measure here it is 0 volt. So this transistor goes to off condition. If this transistor goes to off condition, collector current becomes 0 and now it becomes the open circuit. If this becomes open circuit, the 0 volt state changes to plus 5 volt. So if you can see, there the state has changed from plus 5 volt to 0 volt, and here 0 volt to plus 5 volt. Now again, considering the operation of this capacitor C2, now this transistor is a open switch, collector current is 0 and plus 5 volt is realized. By the meantime, this capacitor C2 gets charged. If it gets charged to VC2, maximum voltage, this maximum voltage is realized at this point. So VC2 is greater than 0.7 volt, which means VB is greater than 0.7 volt, which makes the collector current to go to the saturation value. If the collector current goes to the saturation value, this again acts as a closed switch. If this acts as a closed switch, the state changes again to 0 volt. So if the state again changes to 0 volt, the measurement of VCE is 0 volt. It is realized as 0 volt here, this point, which again switches off this transistor. If this transistor is switched off, this becomes an open terminal, and if VCE voltage is measured, that is VCB is measured, again we get 5 volt, plus 5 volt. So again it is plus 5 volt for a certain duration. So this is how an astable multivibrator works, by changing its state from 1 to 0 without any external trigger. Thank you.